not counting too well today. Okay. Slideshow. Current slide. All right. That's not where we left off, I don't think. Nope, we're one slide before that. Well, maybe it is where we left off. No, I see, yeah, sorry. Okay, this is where we left off. All right. Oh, I haven't marked all, have I? Let me do that. The light on. Jackson's here. Shelby, not here yet. Colton Boyd is here. David Brown's here. Josh Brown's not yet. Aaron's here. Krista's here. Takia is here. I see you behind the light here. Okay. Alexis is here. Frank's not here yet. Justin's not here yet. Kayla is here. Peyton's not here yet. Jalen's not here yet. Chris is here. Craig's not here yet. Curtis not here yet. Sabrina is, oh, she withdrew, so we're part of it. Kara's not here yet. Nathan's not here yet. Kiana is here. D'Anthony's not here yet. Sarah's not here yet. Shay's not here yet. Josh Smitherman's here. Colton Turner's not here yet. Tay is not here yet. And Brandy's not here yet. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. 3, 5, 8, 10, 11. Got it. All right. Now, we will be, okay. Oh, and we are recording. Let me also say this about office hours. Today's sort of normal, I think, as normal as it can be. I will be leaving. My office hour is supposed to be 2 o'clock on Wednesdays. I'll be here past 2, but I will be leaving earlier than normal. Usually it's 4:45 or 5, 5:15 or something like that. We'll leave a little earlier because I've got someplace I've got to stop at before they close on the way home. So since I'm supposed to leave at 2 anyway, I'll be leaving probably 3 or 3:30 or something like that, maybe even 4. All right. But tomorrow, normally office hours tomorrow is 12:15 till 3:15. They'll tomorrow be 12:15 to 2:15 because we have a faculty meeting at 2:30. So I'll be at the faculty meeting at 2:30. I'll have to leave beforehand. Okay. Friday, normally office hours 7:45 to 11:45. Not Friday. You know why? Veterans Day. Okay, and Shay is here. The school is closed. State holiday. No one will be here Friday, so don't come Friday. Next week should be back to fairly close to normal, I hope, again. All right. Any questions before we get started today? All right. We left off on page 212, about the middle of the page. In this paragraph it says, recall to check a division problem. What do? We multiply the divisor times the quotient, add the remainder. Y'all remember that back when you were in grade school, right? Division undoes multiplication, so how you remember subtraction undoes addition. How do you check subtraction? Add the 2 bottom ones, see if you get the top one. Well, same thing here. When you divide what goes into it and what the quotient is, multiply those together, add the remainder. So here's another way to write that. The dividend is equal to the divisor times the quotient plus the remainder. Saying exactly what it is. Sometimes the remainder is expressed as a fractional form. I don't know if you remember that. When you had, say, 7 left over and you divided by 12, then you write your answer as 7/12. Okay? Same thing you can do here. And what you do basically is, it's all good math. Everything's good about math, though. Get the pen activated. If we divide this term by the divisor and divide this term by the divisor, if I could spell, and divide that term by the divisor, if I could spell it, okay. Notice here the divisor goes out, and what do we have? Dividend divided by divisor, okay, is equal to quotient plus the remainder divided by the divisor, just like you did back in long division, okay. Now, if the divisor, now this really is a different paragraph, okay. This paragraph here is going to start 3 examples away. 3 examples away. So let's pause here and go back and do example 2. Divide 2x squared minus 3x plus 1 by x minus 5. What do you put where? What goes where? X minus 5 goes outside the house, knocking at the door, wanting to come in. Okay. Okay. Right, exactly. 2x squared minus 3x plus 1. All right, yeah, you got it set up right. And just as David was saying, you be sure your divisor is decreasing order of the powers and your dividend decreasing order of powers. Not only decreasing order of powers, but if it happened to skip a power, either place, you put in a 0 for that power. It's like if this had been a 2x cubed minus 3x, you write it as 2x cubed plus 0x squared minus 3x. You have to insert a 0 for any missing term. Okay, this doesn't have any missing terms, so we proceed from here. What do we do first? Any ideas? X will go into 2x squared how many times? 2x times. Then what do we do? Multiply. 2x times x is 2x squared. Fantastic. That's what we designed it to do. Next. 2x times negative 5 is negative 10x. Very good. Now what do we do? Change signs and add. You're subtracting, but that's how you subtract sign numbers. Change that to a minus, that to a plus, and add. Well, these add to 0. Good. That's what we wanted them to. Those add to 7x. Now we bring down the 1. Okay? Now what? X will go into 7x how many times? Plus 7 times. And then what? X times 7 is 7x. Good. We wanted that. 7 is negative 35. And then what do we do? Change signs and add. What does that give us? That goes to 0. Good. We wanted it to. Next. 36. Okay. Now you can either write your answer as the quotient is 2x plus 7 with remainder 36, or writing like we did just a minute ago, we could write this as plus 36 over what? Say again? Over the divisor, x minus 5. So there, you could write the answer that way. You could say quotient is 2x plus 7 with remainder 36, or just write it this way. The answer is 2x plus 7 plus 36 over your divisor, x minus 5. That's what that last slide was telling us.
Do we always change those signs?
You can subtract if you know your rules for subtraction, for sign numbers. But guess what those are? Change signs and add. Okay, so that's why I do it, because it makes it easier. But I do want to point something out to you. I'm glad you asked that. Notice these went away. Right?
Yes.
And these went away.
Yes.
Right? Okay? So, in effect, just keep in mind, you change signs, added, that's what happened. Okay?
When you change signs, you subtract.
Okay, yeah. When you're subtracting, that's what you're doing. What you do is change signs and add. That's what subtraction is in sign numbers. All right, good deal. Hang on to the thought, though, because we're going to come back to it in just a few minutes. Now, I saw something down the hall, and it just sort of saddened me. The class down the hall was taking a test. I thought, do they not know that in 30 minutes they're going to be interrupted? Maybe it was a quiz and they have to be through before then, but I thought, yuck, okay, that'd be terrible to have the fire drill in the middle of the test. Okay, next. But we love our test. Okay, divide this. T cubed minus 8 by t minus 2. What goes where? T minus 2 outside the house. T cubed, is that what I heard? Okay, what next? We're missing some terms. No, plus 0t squared. Next. Plus 0t. You have to account for every term. Next. Not minus 2. Your dividend. Minus 8. All right, what's the question? Well, what do they stand for? Nothing. Okay, so you haven't added anything to it. You just had a placeholder. And you'll see coming up in just a minute why it's important. Because you need to have the placeholders. Okay? But you see, that's not adding anything. That's not adding anything. All it's doing is stringing it out so you have a placeholder.
So it's just the T with our.
What's that?
It's just the T.
It's just to keep, identify every term. Like you have 1, 0, 3, 2, 1, 0, blast off. You know, we have everything covered. You need those in there. And here's why. What's your next step? Okay, and what would you do? T will go into t cubed, t squared times. And then what? Multiply, and that gives you t cubed minus 2t squared. Okay, let's just imagine that we put our 8 there, minus 8 here. Can you subtract this from minus 8? No, you can only add or subtract like terms. So you need this to be the same term that is. That's why we put 0t squared in. Okay? Now, what do we do next? Change signs and add. So that would be a minus. That becomes a plus. These go to 0. Aha! Look at that. They go to 0. They disappear. Good. Next. 2t squared. And then what? Bring down a 0t. Bring down nothing. Okay. Nothing there. But bring it down just for have a space there. Next. T will go into 2t squared how many times? Plus 2t times. Then what? Multiply. 2t times t is 2t squared. Ha, good. Next. Negative 4t. And then what do we do? Change signs and add. What does the first give us? 0. Next gives us 4t. And then what do we do? Bring down your negative 8. See, now it's in the right place. You needed those placeholders so you could add like terms. Okay, now what? T will go into 4t plus 4 times. Very good. Now what? Multiply. 4 times t is 4t. Negative 8. Guess what? Our remainder is 0. That meant that is a factor. It goes into it exactly that many times. But you know what? We knew that already, didn't we? We didn't need to do all this, but we were practicing. Okay, practice makes perfect. Why did I say we didn't need to do that? Notice what t cubed minus 8 is. A difference of 2 perfect cubes. We could have factored that, couldn't we? How does that factor? t cubed minus 8. What would be the factorization for that? Remember, that's that special rule. Yeah, I can tell you remember. Yeah. Huh? Okay, it'll be t minus 2. And then what's the next part? T squared. Opposite sign. No, plus 2t. Remember, it's opposite the product. Then plus 4. Okay? And then, if you divide this by t minus 2, guess what? Your t minus 2's go out, and you have left t squared plus 2t plus 4, which is exactly what our quotient is. See how this all works together? If you could factor, factor. But if you didn't see you could factor, divide. They do the same thing. Factoring is just another way of dividing. Now, that will work only if your remainder is 0. If that remainder been something else like the last problem, no, you can't factor and get it to work out that way. Only if the remainder is 0. It goes into it an exact number of times. All right, good deal. Any questions about that? They got the right answer too. Good for them. I didn't check the other one. Yeah, they got it correct too. Now, they also did something on the last one, and they didn't do it on this one. Why are they not consistent here? I'm not sure. On the last one, they said at the end, x cannot equal 5. Obviously not. Now here, they should still say x cannot equal 2, or t cannot equal 2, because you can't go around dividing by 0. But they didn't say it here. It's okay. Can we go to the next one? You okay? All right. Let's do example 4. Divide y cubed plus 3y squared minus 2y minus 1 by y squared plus 2y. What goes where? Y squared minus plus 2y goes outside the house. What goes inside? And notice here, okay. Now, you could put a plus 0 here. But since it's at the end, it's not really necessary. But if you wanted to count for every term, 2, 1, 0. You could put a 0 at the end, but it's not necessary here. What goes inside the house? Y cubed plus 3y squared minus 2y minus 1. Did we account for every term? Yes, we did. So we're okay. And where do we start? Y times. And then what? Multiply, and that gives us y cubed plus 2y squared. And then we do what? Change signs and add. Okay, so changing that second plus to a minus. It's easy for me to do, maybe less easy for you, but okay. And then we add, the y cubes go out. Good. And what do we have left? Y squared minus 2y. Bring down that. Now let's see. Nathan's here. Oh, I know you're in here somewhere. I just got to find you. There you are. All right. And by the way, 2 of you came in since the call roll. Anyone else come in? Okay. Remember at, good timing, 8:30 today, guess what we've got? A fire drill. Okay. What do? We go down this half flight of stairs, take an immediate left, go down a full flight, go out of the building. Normally, on a real fire, we'd go to that parking lot down there. But they want us to meet in the back of the building, so we'll hang a right and go up that little parking lot by the library and stuff, then go up the stairs and then go to the back part of the parking lot there. Still far away from the building. Yes? Oh, okay. What's that about this? Okay, now, question. Okay, here, y times y squared is y cubed. Y times 2. Oh, it's a positive 2y. So it's positive 2y squared. But then we change signs to add. Remember, that's how you subtract sign numbers.
Are we still doing this?
Is it? Okay, they said they weren't gonna do the alarm. Okay, y'all know where to go. They lied, okay. Y'all know where to go. Go out the door, down, and then go to the back. I'll lead the way, okay? Make sure everybody's behind you. Okay? And walks, don't run, never run. Okay. Technically, we would. Yeah, we will be coming back. Normally, you wouldn't gather up your stuff, but since you know it, it's fine.
But you get what I'm saying?
What's that?
You see what I'm saying? It was,
The minus there?
but it was wild plus too. You know, it was wild times.
Right. So what I did was change signs in there.
Okay.
Well done, team. Everybody's back good. Not that I thought you would miss it. Okay. Now, what's that? Just a couple of things, and it's just minor. Some of you did take some time getting your stuff together. In a real fire, you leave. Okay. I have to get my roll book just so we could have that. But other than that, you really should leave your stuff. If it's handy, grab it and go. But don't be packing a bag. You know, if it's a real fire, get out of the building. Your stuff can perish. Okay. You know, I know it's expensive, but it's better than you perish. Okay. Huh? Yeah. 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 Yeah, I know. Yeah, first I would definitely probably go for that too. But in reality, you get out. But y'all were very good about doing careful, slow, no rushing, and what's that? Well, they were doing what they were told. They were just told to do the wrong thing. I had emailed her and said we should not practice wrong behavior. Okay, Tay is here. You missed the excitement, didn't you? Okay. All right. So, good deal, though. Y'all did it well. I know if it was a real fire, there'd be a little more adrenaline going, and you'd be tempted to rush. Go down rapidly, but not fast. Don't call somebody else to do it. Now, I did something I probably shouldn't have done, but still I think I should have. When there was a guy who was on crutches, even though he wasn't in my class, I want to make sure he got out of here. It's my responsibility. So y'all were good to stay together, even though I wasn't there. That was good on your part. Then when others were coming in later, I wanted to get behind them too, because I'm expendable. Y'all are not. Y'all are the future. I'm the past. Okay, so go for it. Okay. Now, Jackson, did this answer your question you had about the minus sign?
Yeah, you said you just need to subtract.
Yeah, you subtract. Now, actually, one like this, when it was plus and plus, that's subtracting like we used to do it. 1 from 1 is 0, 2 from 3 is 1. So, yeah, you didn't have to change signs there. But when there is a minus sign, I find it easier to change signs than add, because minus signs cause more problems when you're subtracting sign numbers. So, but if you could do it without the changing signs and adding, do. Just know it's either subtraction as is or change signs and add.
We're looking at the number outside the house. The number outside the house is plus.
It's what?
So plus. Y squared plus 2y.
Right.
So we think we adding now stuff.
Okay. Wait. Okay. Right. Okay. There's another reason I'm doing it, but let's go back. Let's go back and do it. That came up plus and plus. You're absolutely right. Now, when they are all pluses like this, there's no problem with subtraction. Because I know y cubed from y cubed is 0, 2y squared from 3y squared is y squared. So if it's all pluses, then I wouldn't bother to change signs. Except, that's the rule for the rest of it, so I get into the habit of doing it. So, yeah. Now, if this had been a minus here and you go to subtract, some people tend to make errors. Or if this was a minus, you go to subtract. People tend to make errors. If you change signs and add, to me, that reduces the possibility of error. On this one, you could have done it just like that. Okay? But anyway, you got your y squared, brought down to minus 2y. What's the next step? How many times? Plus 1 times. Very good. Don't forget that. I mean, it goes into it 1 time. Then what? Okay. 1 times y squared. Is that what you said? Okay, do the y squared first. Yeah. 1 times y squared is y squared plus 2y. And now what? I like changing signs and adding. Otherwise, I find students make more mistakes, okay? But, okay? And then when you change signs to add, these add to 0. That's what you want. And we got it. But what do those add to? Negative 4y. See, adding sign numbers to me is easier than subtracting them. That's why I change the lines and add. And now what? Bring down the minus 1. But guess what here, folks? I should have been pointing this out every time. Will y squared go into minus 4y? No, it won't. This, then, is your remainder. It's important to bring down that minus 1. That was part of the problem, but this won't go into that. So when your degree of your remainder is less than the degree of the divisor, you're through. So what would we do at that point? You could, okay, then you could add a minus 4y minus 1 over y squared plus 2y. Very good, okay? Now, I can almost guess that someone would say, I don't like that minus sign there. There's 2 minus signs, so you could change this to a minus and change both of those to plus. Still a correct answer, but if you don't see that, if that's not something that you want to do, go with what you know is right. Okay. Here's what I say. If you're doing homework problems, hint, if you're doing homework problems, yes, do them. See what the back of the book has, and then write them in that form so you know you got it right. If it's me on the test, I'm going to look at it. If I can see you got everything right, I'm going to give you credit. However you write it, okay? I'm not just picking, oh, you have to have it in this form, you know. That's what those packages do. They make you get it in a certain form. If you have it right, it's fine. If you say y plus 1 with a remainder of minus 4y minus 1, I'm happy with that. Or if you write it like that, I'm happy with it. Or if you put this as minus and those pluses, I'm happy with it, you know. You can even factor that denominator if you want to. I'm happy with it, as long as it's correct. Okay? If you give me a wrong answer, you're not going to get full credit. But give me a right answer, no matter what form it's in, I'm going to give you credit for it. Okay? Now, always reduce things. Now, I sort of made almost a little joke about that. If you could factor something out, like if this was a 4 squared minus 4y minus 8, then you could factor out a y plus 2, then, yeah, factor the numerator and the denominator and simplify. Always simplify, but the rest of it doesn't matter how you leave it, okay? That one you can't simplify, so you're done. And let's see how the book left it. That's my clue here. They left it both ways. They put the quotient with the remainder just like we had it, or they write it as y plus 1 plus, and they put the negative 4y minus 1 over x, y squared plus 2y. So either way is fine. Good questions. Did that answer them? Okay. What's that? Is that not the fan room? Yeah. It's what? Yeah, okay. It may be making a little more of a whine. I don't know. They shouldn't have shut down the fan for the fire drill. In reality, they probably would have, you know, but they shouldn't have. But that may be why it's going. I don't know. All right. Now, remember I said we went through here. The rest of this slide is what comes next. If the divisor is in this form, x minus k, okay? Now here's how I reference that form. Coefficient of 1, exponent of 1. For your variable, if the coefficient is 1, the exponent is 1, then you can use synthetic division. If it's x minus k. What if that was x plus k? Still fine. Coefficient 1, exponent 1. You can still do it. Where the coefficient of the x term is 1, and they don't say it, the exponent of the x term is also 1. Then the format of the division process described in this section can be simplified by a procedure called synthetic division. Are any of you familiar with it? Have you done it before? Okay. Actually, it makes things so much easier. Okay? But if you like long division, you can always do long division. But you can only do synthetic division if it's in that form. So this procedure is a shortcut for this type of polynomial division. If you are continuing, I don't like continuing to study college algebra, then you'll want to know synthetic division. It just makes life easier. If you're not continuing to college algebra, then you probably will not need the shortcut, and the long division process will be sufficient. And if you like to work hard, it's fine. Okay. If you're lazy, you might want synthetic division. First, let's consider an example and use the usual division process. Then, in a step-by-step fashion, we observe some shortcuts that will lead us to the synthetic division procedure. And frankly, they drag this out like crazy. There's easier ways to do it, but let's see what they say. All right, so here is our problem. Consider this division: 2x fourth plus x cubed minus 17x squared plus 13x plus 2 divided by x minus 2. Does this qualify for synthetic division? Yes, because the coefficient of your divisor is 1 and your maximum exponent is 1. It qualifies. We're going to do it long division. Yay, team. Okay. All right. Justin, right? Sorry, I'm staring into the light. It drives my head crazy. All right, you missed the funny games. We had a fire drill at 8:30. Yes, for real. No, it was a drill. No, I'm just kidding. No, okay, sorry. All right. So we're going to do long division. We know how to do that. Put the divisor outside the house. Put this inside. Make sure you account for every term. Yes, it's accounted for. We're fine. And then we proceed. And what do? X into 2x fourth is 2x cubed. Okay? Then we multiply. X cubed times x. 2x cubed times x is 2x to the fourth. 2x cubed times minus 2 is minus 4x cubed. Now, they don't change signs and add. They do, well, they do, but they don't show you doing it. Okay? Notice these subtract away. I also want you to notice something else. The x's we're just writing down. Okay? They stay right where they belong. So we're just writing. So we really don't need those x's, except when we write our answer, go and put them back in. So we'll do that too. So what do we do next? After we multiply, we subtract, change signs, and add. I would put a minus plus, and then that would get this away, and this is 5x cubed. If you're subtracting, this is what you do. Change signs and add. Okay, so that's what we were doing. Okay? Then, x will go into 5x cubed, 5x squared times. And then, multiply 5x squared times x, 5x cubed. See, these things are disappearing. 5x squared times minus 2, minus 10x squared. Now, you're either subtracting or change signs and add. I like changing signs and add. Change that to a minus, that to a plus. This goes away. That leaves you negative 7x squared. Very good. Then, x will go into negative 7x squared, negative 7x times. There's a negative 7x. Okay, then what? Multiply negative 7x by x is negative 7x squared. Negative 7x times negative 2 is plus 14x. Very good. Watch those signs. They trip you up. Then change signs and add or subtract however you want to. That goes away. This becomes a negative x. Okay? Then x will go into negative x. Negative 1 times. You got to account for the sign too. Negative 1 times, and then negative 1 times x is negative x. Negative 1 times negative 2 is plus 2. And guess what? It goes exact number of times. The remainder is 0. So this will go into that exactly that many times. And if you wanted to, you can go back and multiply those together, and you'll see that does work. Okay. Yeah.
I know they did that, but you was going to want to change the signs.
Yeah. What I would have done, but I can't erase it because they got it there. Change that to a plus and change that to a minus. And when you add, that goes to 0 and that goes to 0. So you come up 0 either way. Yeah. But I wouldn't have, when I see they're identical, I know they're going to subtract away. So I'm lazy, I don't do it then, but most of the time I do. All right, now, here's a few things to note, okay? Did we really use, because the coefficient here is 1, that didn't change anything. Every time we divided, we carried up exactly what that number was. Whoops, not there, okay. Because the coefficient was 1, okay? And this one, let me get my pen back, okay? And this was a, there is no, the number was -1, it's still -1, okay? So really, the x's were just window dressing, okay? They were just filling in. You have to have them in your answer, you have to have them in the problem. Now, the other thing is, since this isn't doing anything but wiping out this term and that term and that term, they're all disappearing, you can almost forget about this. And since we were changing signs and adding anyway, why not put a +2 here and do it? Now, this sounds strange, and it is, but this is leading to what we do with synthetic division. Let's see what they, yes?
Is your recording on? Because I'm not able to watch this.
Yeah, the recording is on, yeah.
Thank you.
Oh, I wonder if I turned the recording off during the fire drill. I may not have, so there may be a big, long, dead period of recording. So when you listen to it, don't think it's wrong. Just hang on to it. I'm sorry, I forgot to turn off or pause the recording. Yeah, I'm glad you thought of that. I wish I had. Okay. All right. Note that because the dividend, this thing, is written in descending powers of the x, the quotient is also in descending powers of the x, of course. In other words, the numerical coefficients, remember, I was pointing these out, they are just the number part, you just put in the variable. Notice because you were dividing by x, each one of the exponents go down by 1. And we did that, we knew that. Okay, so in other words, the numerical coefficients are important numbers. Thus, let's rewrite the problem in terms of just the coefficient. Okay, the same problem, and I wish they hadn't put the 1 here, okay? But they did, it's okay. And if you just remember, that started out being an x to the 4th, so this is going to be an x cubed. That's all you have to remember, then they go down from there. So if you did this without the x's in here, everything does fine. 1 will go into 2, 2 times 1 is 2, 2 times -2 is -4. Change signs and add, these go away, that becomes a 5. Bring down to -7, 1 will go into 5, 5. 5 times 1 is 5. 5 times -2 is -10. Change signs and add. That's what you're doing every time, okay? And just continue the process. So you see the x's were just something for you to write down. You got to go back and write in at the end. Now observe that the numbers that are circled are simply repetitions of the numbers directly above them. This 2 was here, this 5 was there, this 7 was there. Now I don't know why they circled this one. Oh yeah, it's that one, that's that one, this is this one, and this is that. Okay, so they're just repetitions. Okay, so if you don't like to repeat things, we can condense that some. This is a weird way to do it, I think, but it's the way the book's doing, so I want to follow it. Therefore, by removing the circled numbers, we can write the process in a more compact form. Just forget the 1 here, okay? A -2, but then you're having to change signs and add every time. Well, since you're changing signs, why don't you just change this sign, multiply, and add, okay? And you'll get the same thing that we did before. Now, this is weird the way they've done it, but, okay. So I'm going to turn this around in a minute and hopefully have it make a little more sense, okay? They've omitted the repetitions and we're 1 and it is okay, submitted. Note that line 4 reveals all of the coefficients in the quotient. Okay, so why write that? Okay, except for that first one of 2. this is a strange way to approach this. I'm going to show you how I would go. So here's what they wound up doing. Okay? Here's synthetic division. I still don't like the division sign here. And, well, it's not yet. Remember, it's a minus 2. Okay? And they're going to have to change signs and add. Okay? So, what you do? So, they've eliminated the ones on top and just written everything down here. There's your answer, by the way. 2x cubed plus 5x squared minus 7x minus 1. That was our answer. Okay? Just you got coefficients only. Now, finally, here's what they do. By changing the constant here to a plus, then you don't have to change signs and add. You just multiply, add, multiply, add, multiply, add. So that's finally synthetic division. Okay? So here's the rule. I still don't like putting the house here. Put the opposite of whatever that number was. It was x minus 2, so put a plus 2 here. Write the coefficients here. Now, they don't tell you this, but I do. What I do next is count how many coefficients I have. How many?
Write it out and show us what you do.
Okay, yeah, we'll do it on the next problem, okay? So I'm just rewriting the same thing for this, okay? But what I would do, I count the number here. How many? What was the original problem? X to the 4th. This is always one more than your maximum exponent. Always, okay? If not, you need a 0 in there somewhere, okay? They didn't tell you that part. So here's what you do. Put this on the outside, the opposite of this. Put your coefficients here. Skip a line, draw a line. Okay? That sounds strange. The book never says it. Bring down that first number, the 2. Then you do this. 2 times 2 is 4. 4 and 1 is 5. 2 times 5 is 10. 10 minus 17. Yeah, it's negative 7. 2 times negative 7. Negative 14. 13 and negative 14 is negative 1. 2 times negative 1. Negative 2. 2 minus 2 is 0. This is your remainder. Okay. Basically, it's that same thing. Okay. Let's consider another problem that illustrates step-by-step procedure for carrying out the synthetic division process. So here's the problem. 3x cubed minus 2x squared plus 6x minus 5. Divide that by x plus 4. What do you reckon we put up? Okay. Does this qualify for synthetic division? Yes. Coefficient 1, exponent 1. So what you put outside the house now? No. The opposite, negative 4. Put a negative 4 on the outside. They didn't do it. Okay. What you put inside the house? 3, negative 2, 6, minus 5. How many numbers is that? 4. What's your maximum exponent? 3. Yes, it works. Okay. So they've started it for us. They just didn't put the, what goes outside? Negative 4. Okay. Now I don't like that division sign. It looks too much like division. What I do next is skip a line, draw a line. Now I've never read that in the book. I just say it. Okay. Fine with me. Okay. Yes. Then bring. It's pretty simple, huh? Bring down the 3. Now what? Negative 4 times 3 is? Negative 12. Then what you do? Add. What does that come to? Negative 14. Now, multiply. Negative 4 times negative 14 is big numbers. Okay. That's a 6. 56. You got it. Then what? Yes.
Just slow it down. You're doing what? 4 times 14?
Yes. Negative 4 times negative 14. That's going to be a positive 56. Okay. Then add, and what does that give you? 62. Big numbers. Okay, next. Yo! That's a minus 248. Right? And then add that to minus 5, and you get minus 253. Is that what you said? Okay, good. Okay. I don't hear well, so I was hoping you said that. This, by the way, is your remainder. So I separated off that way. What is your answer? These are the coefficients. Fill in the variables. x what? Squared. You drop it 1 from what it was before. Minus 14x plus 62 minus 253 over x plus 4. Do it just like we did before. There's your answer. Or you could write it as 3x squared minus 14x plus 2 is your quotient with a remainder of minus 253. That's it. Okay. Notice the remainder doesn't have any variable in it because your divisor was power 1 and the remainder has to be less than the power of the divisor, so that's power 0. So it's just a number. Always, if there's going to be a remainder, it's just going to be a thing. So, yeah.
How do you know to make that 3x squared?
Because what you do, these are your coefficients. Remember, these are coefficients, right? And because we did an x into x cubed, you know that's going to be an x squared. That's where you go back and remember, yeah, where did this come from? Okay.
When you said you drop it down 1 layer, is
Yeah,
that
you drop
always
it.
the case?
Yeah, because remember, you're dividing by power of 1. Remember? That's the requirement. It has to be degree 1, so when you divide that into this, it's going to drop it 1 degree. So yes, it will always be with synthetic division. With long division, if that was x squared, no, it's going to drop it by 2. But you don't use this in that. It won't qualify. All right, let's see if they got it right. Let's see on the next page. They do the minus 4 on the outside, good for them. Then they brought down, they skipped the line, draw a line, but they didn't tell you that. Then they brought down to 3, and then they started the multiplying and adding. Minus 4 times 3, minus 12, add, minus 14, multiply. Why do they do it like this? I don't know. Negative 4 times negative 14, positive 56, add to 6, 62, multiply. Negative 4 times negative times 62 is minus 248. Add to minus 5, minus 253. That's your remainder, and look how they wrote their answer. Good for them. Okay? 3x squared minus 14x. Those are your coefficients at the bottom, plus 62 with a remainder. I like to separate that off to remind myself that's the remainder. Remainder minus 253 over x plus 4. Because originally your problem was x plus 4 was your divisor. Remember that. Now, you could have put plus here and a minus up there. That would have been fine. Nothing wrong with that. If you don't like that minus sign there, put a plus there and put the minus up there. Same answer. Right? Good deal. Any questions? How are we doing on time? 7 minutes. Good. We can do that. This is one we want to do. We're not going to have them messing us up. You tell me what to write. Find the quotient remainder for this. Okay? First, how do you want to do it? Long or synthetic? Thank you. Okay? Does it qualify for synthetic? Yes, because the coefficient is 1 and the exponent is 1. Good. So what do we put outside the house? I'll show you the way I do it. Second? Not negative. Change that one. 1. Here's why, by the way. If this was indeed a factor, x minus 1, if that was a factor, we say x minus 1 is equal to 0, add 1 to both sides, and you make it x equal 1. So that's what we put on the outside. We're not there yet, but that's why we do that. You just sort of like you move it across, okay? So don't worry about that. Just change the sign of that one. So you put a 1 on the outside. What goes in? I like to do my house like this. What goes on the inside? 4, negative 2. 0. Very good. You have to account for every term, remember? Second, 6. And what? Negative 1. And then what do I suggest you do? Count how many numbers you have. What is it? 5. Is that one more than this? Yes, it is. So if you left out that 0, you get a 4, and that's a 4. You say, wait a minute, folks. Something's missing. Okay? That's how you catch yourself. Okay, now what's the next really important? Yes?
How do you choose the 0?
How do I what?
How do you put the 0 in
Okay? Because you look at the terms. This is the x to the fourth term, x cubed. We don't have an x squared term. You got to have one. Just like we put one in before, 0x squared. You put a 0 for the x squared, then 6 for x, and 1 for the constant. You have to account for every term. Remember earlier, when we did those, we had to put them in, make sure they were there. You do it here too.
Ascending. You got to go from ascending to
Yeah.
descending.
This is 4, 3,
I
no
was
2,
trying
so
to
you
say-
put a 0 for the 2.
You
Yeah.
missing the two. You missing the X2.
That's why I
No,
was
it's
like,
just
where's
the only
your-
thing is you.
Yeah. Good deal. Excellent. Now what? You better remember this. Skip a line, draw a line. Very good. Now what? Bring down the 4. Now what? Multiply. You get? Then? Add. Why we change the sign to begin with? So we can add. Okay, so what does that come? 2. No, not negative 2. 2. Okay? If you had 4 pieces of pie and you ate 2, you would not have 4 left. You'd have 2 left. Oh, never mind. Okay. I like to think in terms of food. Next
1 times 2.
is
2.
and
1 and 2.
0 and 2 is 2. 2 again. 8. You're adding.
1 times 8 is
8.
7.
7. That's your remainder. So what's your answer?
4, 2, 2, 8.
Now you put back in the variables. 4x cubed plus 2x squared plus 2x plus 8 plus 7 over x minus 1. You got it. Very good. Way to go. Does that make sense? All right. If you don't like synthetic division, you can always go back to long division. It works. You'll get the same answers. Huh? All right. Yeah, I can tell you're lazy. Okay. All right. All right. All right. Want to see how they did it? Everybody got this? Okay. So we'll erase all that and let's see what they did. Oh, they write it funny, but they do okay. Put 1 on the outside and your coefficients on the inside, accounting for every term. You're missing an x squared, so put a 0. X minus 1. Then they skipped the line, drew a line, though they didn't say it. Okay? Bring down the first 4. That always comes down. Then you multiply. 1 times 4 is 4. Negative 2 plus 4 is positive 2. 1 times 2 is 2. 0 plus 2 is 2. 1 times 2 is 2. And 6 plus 2 is 8. And 1 times 8 is 8. Negative 1 plus 8 is positive 7. There is your synthetic division. Now you have to interpret that. And to me, it helps to interpret it, to separate that one out, knowing that's your remainder, and then do that. The original problem, this, divided by that, is equal to your quotient, 4x cubed plus 2x squared plus 2x plus 8 plus 7 over your divisor, x minus 1. Okay? Good deal. Does that make sense? All right. Excellent. Yes. It's time. Oh, such sad words. Okay. All right. That was example 5. Oh, we made it so close to the end. There's a concept quiz, so do that. True, false. Pretty easy. The answer's on the next page. Then do homework exercises, any of the odds 1 through 9. Any of the odds 11 through 51. A whole passel of those. Maybe a passel and a half. Okay, then any of the odds 53 to 63. And we'll begin next time on 4.6. That's on pages 216 and 217. And we'll begin next time on 4.6, which is the last section we're going to cover in Chapter 4, meaning once we finish 4.6, we have a test on Chapter 4. We can't wait, can we? Okay. No, any of the odds 53 to 63. 63. Yeah. All right, good deal, folks. And we will see you next week. Have a good weekend. Enjoy your Veterans Day, by the way.